multiply because we have multiple fractions, okay? So there is a strategy which you're going to learn in the seminar, and you're going to have to remember again in grade 10. And it's going to help you eliminate. In this type of situation, we want to eliminate the fractions. If you look at this, really, by cross multiplying, do you see any fractions in the second line? No, there are no fractions. So we did eliminate the fractions. You don't like fractions, so the best way to deal with them is eliminate them. How are we going to eliminate them? What does this stand for? What does this term stand for? What does the term stand for? Yep. Good. Lowest common multiple. Okay. So I'm asking you, what is the lowest common multiple? I'm just looking at my denominators now. What is the lowest common multiple of both of those denominators? Yep. Good. 15. Lowest common multiple. The next thing I'm going to remind you, which I never want you to forget when you're dealing with algebraic equations. An algebraic equation is like a scale. Whatever you do to one side, you have to do to the other side. And that is the problem, especially in grade 10 mathematics. Kids are focusing on the more complicated side of the equation, and they totally forget to do the same thing to the easier side of the equation. So this is actually a grade 10 sort of question that you will get frequently in grade 10. So I want you to remember that an equation is like a scale. Whatever you do to one side, you're going to do to the other side. So for the next couple of minutes, I want you to drop your pencils and just look at me on the board, because this is not difficult what I'm going to do, but for some reason it gets difficult when you do it by yourself on a test. So 15 is a whole number. 15 is always going to sit on top of an imaginary 1, right? I can't forget that. So I have 15 over 1. I'm going to multiply 15 over 1 by this fraction, x plus 1 over 3. Okay, then separated by an addition sign, I have 15 over 1 again, and I'm going to multiply that by x plus 5 over 5. And an algebraic equation, remember I said it's like a scale, so we're going to just erase this for a second. So separated by an equal sign, and then I have 15 over 1 again. I have to remember whatever I do to the left-hand side, I also have to do to the right-hand side. Okay, so looks a little bit complicated right now, but this is how we eliminate the fraction. And how we're going to do it is, with each term, we're kind of going to cross-multiply, or cross-multiply to reduce. 3 goes into 15 how many times? 5 times. 5 goes into 15 how many times? Okay. Now I want you to closely look at your denominators. Are there any numbers left in your denominators besides 1? No, right? So technically, 1, 1, 1, I could just erase all my denominators, right? Is that true? They can all just disappear. That is your whole objective. To get rid of your fractions, you need to, if you're using the proper lowest common multiple, all your fractions your denominators will go away and you'll have 1, 1, 1, 1, 1. If you do not have 1, 1, 1, 1, 1, you've used the wrong lowest common multiple. Okay? So now I can rewrite this question as no longer 15, but 5 times x plus 1 plus 3 times x plus 5 is equal to, the denominators even don't exist here. What is 15 times 4? Does anyone know? Yep. 60 is equal to 60. So now we've turned a very complicated fraction question into something that is a lot easier to deal with. Do you know how to tackle this question now? What strategy are we going to use, Justin? Very good. The distributive property. However, what would happen, would I get the same answer if I forgot to multiply the right-hand side by 15 and I had left it as 4? Would I get the right answer? No, because an algebraic equation is like a scale. Whatever you do to one side, you have to do to the other side. So if I didn't remember to do that, even though I did all my other steps correctly, the whole question would fall apart. I wouldn't get the right answer, okay? So this word, the scale, balanced scale, and it makes sense because whatever I'm adding on one side, I'm subtracting on the other side. I'm doing the opposite operations to kind of balance the scale. So you have to keep that image in your mind. So let's go ahead and solve this question. I have my 5 multiplied by x. Then I have positive 5 again multiplied, oops, I want the colors to show up. Keep it with green. I have positive 5 multiplied by x. Then I have positive 5 multiplied by 1. And then I have positive 3 multiplied by x. And then I have positive 3 multiplied by 5 is equal to 60. So 5x plus 5 plus 3x plus 15 is equal to 60. Do I have to move any of my variables to the other side? No, because 5x, 3x, they're all together. So I just have to combine it to 8x, and nothing has to move over to the other side. All those variables can be combined. There is a 60 on the right-hand side. I do have to transpose my positive 5 and my positive 15, turn them into negative numbers. So what does that simplify to? 8x is equal to, what is 60 minus 5 minus 15 going to give me? Then 40, good. And when we divide both sides by 8, your final answer, what is 40 divided by 8? X is equal to 5, good. Okay, so look how many steps. 1, 2, 3, 4, 5, 6. 6 steps, and you might need to ask the test center lady for extra paper, but the more steps you do, the less mistakes you're going to make, okay? And the more part marks I can give you. So even if Ben wrote 7 as his final answer, I could still give him a mark for every single step that he got right, okay? So keep that in mind. Even if you don't get the right final answer, the more steps you show me, the more marks I can give you. Okay, let's look at this question very carefully. What if the question was